I was asking, were you guys able to catch up on the previous sync, or do you want a little, or at least see the overview of yesterday's sync? Anna
Yeah,
was there.
would be great. I didn't watch the video.
So I think we mostly went over. I gave like a brief overview of AST grep and tree sitter, right? And like the actual library code. I think I've already showed you guys that, Eon and Lily, for the most part. I cleaned up a lot of the Ruby parser code, so hopefully it's a little bit more legible now. I still have some cleaning up to do. So I did an overview, but the main point of the overview of how all those things work is to kind of lead into what the API design should be like. I think for us, it's not as pressing because we get to just talk to the Rust library code directly versus their Golang indexer is going to need to specify different data types that it wants. So we went over like the API design. And I can kind of go over what I was
Oh,
presenting that.
uh, hold on this. Why should Go indexer specify data types it wants? I would expect the only thing Go indexer does is that specify I want knowledge graph type of data, and knowledge graph library, Rust library, will take care of handling, getting all the types and everything inside it. So, I
Yeah.
mean, this information shouldn't live outside of this knowledge graph Rust library. Yeah,
Yeah, no,
so,
I'm talking about the embedding side. So
oh, okay.
the there so um we have like our here, I'll let me pull up Excalibur because I think I probably create a ton of confusion without actually properly visualizing this. So maybe I actually made a visualization too. Can you guys see my screen? Um,
Yes.
okay, so knowledge graph. Um, no, I think I made this already somewhere. Um, okay, yeah, so I did make this. So we're talking about this side here. So um, right, this is the one parser library project. It's going to expose potentially Go bindings, right? So that the embeddings team can call into that. We were discussing, part of what we discussed is like, should the Go bindings live, like imagine they have I don't know what indexing process they're using, Dimitri, you probably know better than me. But they have like an indexer that's Golang based, right? Which will talk back and forth with Giddily. Um, we were trying to figure out whether it makes sense that the Go bindings initially exist in the indexer and we just compile against the library Rust crate, or if we should publish Go bindings from this library. That's actually a question for Dimitri. But this might relate to the knowledge graph based on the recent discussion in Slack. Um, but for us, right, we're just going to be consuming the one parser library directly in the knowledge graph project. Um, and then, like you said, it'll be for us, it'll be much simpler, even if we use Go FFI on the server side, because we'll just pass in the file content or file array. And then there will just be output data. We don't need to think about like what data it needs or anything. Does that make sense? Sorry if I was confusing there.
Yeah, yeah. So I think, yeah, we are on the same page here. Mhm. So there will be some bindings for this knowledge graph project, which we will use from,
Yeah.
yeah. Mhm.
Yeah, I
Um,
think having a separate Go bindings project makes more sense, not to move the bindings from one project to another, because we'll most likely need to have these bindings for the knowledge graph server side.
okay. Say that again.
I think we will need these bindings for the embeddings indexer and for the knowledge graph server-side indexer.
Mm-hmm.
So it might make more sense to start from a separate Go bindings project in that case.
Oh, okay. So like a Go bindings for both?
I think so, because it's a wrapper.
Mm. I'm not sure. That's a good point.
So
I don't know.
so is embeddings indexer, will it use some different library than, I mean, the indexing library than the library for passing knowledge graph? Yeah, the library in Zooked binary, which we will use for parsing knowledge graph data, or could we just reuse the same on both sides?
So I think the underlying Rust parser project will be exactly the same. So why not create the same bindings, just expose maybe
Yeah.
different functions? So one for knowledge graph, another for embeddings.
That's because the knowledge graph indexer is going to have a lot of logic um, that we'll need to share, hopefully on the server side. And it'll need to store. That's why I was asking, does it have access to the file system? Because we'll need to store some form of state, intermediary state, like a key value store. So as we parse all the definitions and references, when we want to eventually do lookups like references against something, where you're essentially doing, and when we're building the relationships, we'll want to store all that state somewhere. Um, and so that's why if for instance let's just make a little another thing here I'll do embeddings indexer like this, and then knowledge graph indexer server side. Um, if you go from like this is what I think you were saying, we're missing out on all this logic.
Yeah, that makes sense. So one parser is kind of a subset of the
Yes,
knowledge graph Rust project. Yeah,
yes.
that totally makes sense.
Um, and I can even show you some of the logic there. But that's why we were thinking like for at least the initial version, maybe it makes sense to just shell into it. Because then the, this can be relatively dumb in the sense of whatever, but you had concerns, of course, of Git cloning the entire thing.
Yeah,
So
it's mostly about Gitly communication. So I think Gitly makes everything much more complicated than we would like.
Hmm.
Can you expand a bit on this? Because
Mhm.
even if we use for zero version for development purposes, if we start with in this knowledge server-side indexer, we use this Gitali, which is already present in Zooked indexer. We just use it to fetch the repository files, and we store them on disk, and then we run the CLI executable on these stored files. I agree that it's not ideal at all, but I don't see a big issue why this couldn't work.
So that could work as kind of like a proof of concept, but I don't think we should make that production, if that makes sense. That's a lot of wasted storage. So you first read the data from Gitly, then you save it to disk, and then you parse it from disk. So I don't really see why we need disk if we potentially can parse these files in memory, in batches, and generate the graph and write the graph to disk.
So the only reason would be simplification, that we wouldn't have to implement
The bindings.
this reading from standard input or something at the beginning, but we could do it in the second iteration. Or I mean, for
Production.
the still, yeah, before release, but still in next step. Yeah. I mean, the only additional downside is that we write repository to disk and then read it from disk. But the benefit of this is that this crate, which is in the middle of this graph, at the beginning would use one single interface, how to get the data and how to return the data.
Yeah, export it. Yeah.
So quick
I,
question then. Oh, sorry.
I mean, I'm not advocating that we should use it longer term, but we know at this point that we need this approach because local client side will read always from the disk locally. So we need to implement this approach anyway. So I agree with Vitaly on Slack discussion that it makes sense to start with this approach and then in next step add reading from Gitali. I mean, using adding the direct call to call the Rust library from and passing it data from Gitali directly instead of doing this file system middle step.
Yeah. The Git cloning would be ephemeral, if anything, too. Very temporary. Um,
Well, I didn't mean Git cloning directly. Or the Zookt would still use the Gitali to fetch the change data. It would
yeah,
just store them
that's what
to.
I mean by Git clone. Like just grab all the
Ah,
Git.
okay.
Yeah.
Yeah, I'm just pointing because there was some misunderstanding with Dmitry earlier today that there is difference between doing git clone and just using Gitali client to fetch changed
Yeah.
files.
Yeah. Sorry.
Maybe a quick question for this initial approach, the proposed approach. So
Yeah.
how do we deal with incremental updates in that case?
We can probably add yet another flag to receive list of files and then just and call it, I don't know, incremental and just do differently comparing to directory.
Another thing we can do is uh and I've been thinking about this, how do on the local client side, how do we handle branches? How do we handle um like all of like the tree of changes that you can make essentially, right? Another thing we could theoretically do, I don't know if this will have access, but I could imagine it calling out to wherever the original database is stored, for instance, like the Kuzu DB, the actual file, maybe even run a query and get essentially get a list of changed files, including like you know the matrix, or I don't know. Actually, probably you could just get that from Giddily, I'm assuming, right? I don't know.
That's what Zook does. Yeah. It
Okay.
knows the currently indexed SHA essentially, and it asks the diff from this SHA to the latest version. So you get this diff, you get all these files, so you can perform incremental indexing operation.
Okay. So in that case, yeah, then you would essentially pass only the change files, but you'd have to ensure that we check out this DB, right? I don't know. This is up to Jan and Vitaly, but on the client side, I'm thinking it might be very similar. But we'd be checking out this DB, and then um, or we could check out this DB, do a diff, like you said, or obtain the diff, especially what files are deleted and added, and then run the incremental version of indexing. Um,
Yeah.
the incremental part is a little bit gray right now, because I think we would want to run Cypher queries. The only thing I have to look into is can Kuzu support deletions via their import functionality? Can we change or delete nodes and relationships? I don't know if we can. I think it's just for creating. I have to see. Otherwise, we'd have to do it via a Cypher query. Yeah, I'm not sure. But what were you saying, Dimitri? Or Jan? Were you guys say something?
Yeah, I think you might be right. So yeah, I'm I would be careful of requiring access from this knowledge server-side indexer directly to KuzuDB, because then it tightly couples both together.
Mm,
It would be great that if you do partial upgrade, then the knowledge server-side indexer just passes these changed files to the knowledge graph project. It parses these files like what classes, function calls are there defined and what is removed.
mhm.
But the result wouldn't be probably import file for Kuzu, but it would need to be some JSON file describing what entities or nodes are being added, what are being removed,
Yeah.
and what are calls to nodes outside of these files. Yeah.
Yeah.
I think
That
it
makes
might.
sense.
The truth is that maybe this is overcomplication, because now, based on the recent change that we plan to run this indexing on graph nodes, I mean Zook nodes, then technically this parser may have access directly to the Kuzu database. So if this is a big complication, I think it's still possible or to access the Kuzu database directly, as you have here in the schema. Yeah.
I think we also have an
So
alternative. We might want to store maybe metadata file right next to the Kuzu database in the same folder, in the same directory. And maybe we just have latest indexed hash. So the indexer doesn't even need to go to the Kuzu database to get the diff and index all the recent changes.
Yeah, that's what I was saying is store the list of files that like you said, like a hash in the database, but you could store it probably outside of it too as a separate file. Or what about for V0 just redoing the entire parsing every time and fetching the entire files? If this is fast enough, I don't see why not just reparse the whole thing, other than I guess like cost, right?
So cloning, that's the main problem. If you have a huge repository, you don't want to clone it every time from scratch to fully reindex it. So I think for .com scale, we kind of have to support efficient incremental indexing. Otherwise, it's not just going to work at all server side.
Okay. Yeah, we'll have to figure that out then. So you're saying essentially this has a like file, file metadata, and it's like, got, I don't know, does that have a hash or something, or current files?
No, I was thinking for the indexer itself, we only need to store the hash. So you've just indexed the repository, you store the hash you've just indexed. And then we can call Gitly and get the diffs from that hash to the latest version. So that's what I'm thinking is required for the indexer process.
Okay. And you would store that hash here? Where would you store the hash? Because it has to live beyond the indexer, right?
Probably right next to the Kuzu database files. It will just be a separate file.
Okay. So
I think that we will need more than just last hash from the last indexing, because the problem is that with incremental updates, you still have references to from calls in these changed files to the files which already exist in repository, but you need to create these relationships when you import this data, and you don't know these target nodes in the incremental update because they only exist in the database which contains the full data. Yeah.
so
So
in that case, we'd have to read the database, is what you're saying.
yeah, so we would either need some more generic format, how to in what to return data from the knowledge server side indexer, or this indexer would have to touch the Kuzu database directly. But more we are talking about it, maybe it makes sense to v0 to let server-side indexer to touch directly the Kuzu database if it's simpler. And if this would be an issue in future, we can change it.
Well, I mean, regardless, we're gonna store temporarily. I won't even put that here because it applies to both. We're going to need to store temporarily, like the in what is it, column tabular format, right? Just as an example, like definitions, right, is an example here. My class like that, and the type, is a class. My module, same thing. This is a module. And then also additionally, we'll need to, when we're actually performing the indexing process, define the relationships as well. So relationships, and it would be like from to. I'll separate that out, from to, like that. And yeah, so this is what we're going to be doing regardless, right? Because this is how you leverage the import functionality. Sorry, what's like an example here? Like file path or like file name, right? So in this case, it would be like my file. And we'll do my class, right? So this defines the relationships. So we'll need to do something like this regardless. So it might make sense to store, like you were saying, Jan, an individual, or sorry, a separate tabular format alongside this. It would just be extra storage. But then you could theoretically do a diff on this and do the entire indexing again. But I don't know. The other option is, like you said, do a Cypher query and update via the Cypher queries. Yeah, I think probably indexing initially, at least Kuzu docs, they say when you index initially and you have hundreds of thousands of nodes, to definitely leverage import, right? And then they say, for small amount of nodes, 100 nodes, for instance, use Cypher queries. So, and on the client side, we're going to be using Cypher queries for the incremental updates once the initial indexing is done. So it might make sense to just check out the DB here and run the Cypher queries on the DB. I don't know. Is that possible, Jan?
Yeah, so basically the main question is which component should be responsible for working with the Kuzu database itself, because in original plan, I thought that this Kuzu database should only be updated through the
If I'm missing anything, let me
not
know because I don't know if how I'm not too familiar with the Zoic infrastructure.
through the Zooked indexer, I mean the service which will run on the graph node or Zook node. Here it's basically this knowledge server side indexer, so it should be the only place through which we touch the Kuzu database. So the question is, so if indexer directly should touch these databases, or the indexer should just provide some middle, some intermediate representation of what is being changed, and then this would be handled on the node itself. But perhaps we can just start with changing the Kuzu database directly, since we run the indexer on the same node as the Zooked service.
Want to quickly mention something. Right now we have clear separation of concerns. So indexer only writes data essentially, or that's the main task of the indexer, and web server only reads the data from disk. So I think we should maintain exactly the same separation. So
Yeah, it
indexer
would
should
be
create these databases.
so Kuzu database doesn't support write and read by multiple connections. So what we would do is that we would create a copy of this read-only Kuzu database if we need to update the repository. Then this indexer would work with this copy of the Kuzu database, and once all the changes are done in this copy, we would replace the original Kuzu database with this updated one. Yeah.
Yeah. That's what I was thinking, but I don't know. It's more up to you guys.
Yeah, I think it's something to investigate further on server side. We can investigate asynchronously next week, I guess.
Mhm.
But I don't see a blocker if we would allow the indexer working with copy of the Kuzu database directly. Probably it should be possible.
Okay. Cool. So really the two things to think about is initial indexing and incremental updates. Those are the two phases. So I think initial indexing is pretty clear. We just have to figure out incremental updates. Um, Billy, were you going to say something?
Not really, so we should try. I don't know.
Okay. Um, cool. So for the API side, at least for the one parser, I'm hoping it's kind of clear, but I can walk you guys through that if you want, um, on how it works. I think one of the main questions though is like the Go bindings, more for the embeddings team, uh, and that was an action item. Pam and I had after was like, where should the Go bindings publishing happen? I know Anna's doing research on publishing from the project itself. So what Kuzu does is, and it'll probably apply to us too if we eventually go with FFI. But I think if we're going with Shell, it doesn't apply with us. Um, but Kuzu, the way that they do the bindings, I don't know if you saw, is they build the C++ binaries themselves, the same thing that CGO will compile against, and then they enable the CGO flag, right, in the actual Go module source code, and then they publish the Go module source code. So then when you check out the Go module source code, I think it'll also check out the binaries themselves, and then CGO will compile against those when you install your Go module, essentially. Um, um, and they just commit the binaries directly to source code. But I don't know if that's what we want to do.
So since we already ship the Elasticsearch indexer, that might be not really an option for us because we would need to change how we compile it for Omnibus, how we compile it for other installation methods, because we already have this compilation pipeline for the binary because we ship it everywhere, dedicated self-managed.com. So maybe to avoid these issues, it should be just a separate Go bindings project. We fix all the issues there and we expose a regular Go library we can use everywhere.
It makes sense to me. I don't know. Anna, what do you think?
Yeah, that's something to try for sure.
Okay. And if anything, we could put this in there too, which would reduce some of the complexity. It would just be one project to work off of. The only
Sorry,
downside,
put some of what in there?
like we could theoretically put the bindings that would come out of the knowledge graph itself in there. We just don't want to compile the knowledge graph stuff specifically. Like it would probably be two separate Go modules, but you could put it in the same project so it uses the same pipeline. But I'm wondering if there's like a more simple way to. But that makes sense to me. Creating like a Go bindings project would reduce the blast radius.
Would it make sense to keep them specific to the Rust project in the sense that like, so you'd need write separate headers, you'd need really separate bindings for each one.
Yeah. Yeah, it'd probably be better to keep it specific.
So we would have both. I mean, there will be different code bindings for the one parser and for the knowledge graph project. So would we keep both in one project? I think it probably makes sense.
Yeah. I'm for whatever's more simple. This is kind of ugly.
How much overhead there is in this knowledge graph project? Would it be realistic to expose only one set of Go bindings for both embeddings indexer and knowledge server side indexer, or is it too much extra code for the embeddings indexer?
That's what I'm wondering. Like maybe it should just be one project.
Yeah, I have a question. How this embeddings indexer will be used the same way as we gonna use knowledge graph project?
So this indexer is called from Rails. So actually on a sidekick node, we shell out to this binary, it performs the indexing operation and exits. So in this case, it's different. It's stateless, essentially process that runs and exits.
Okay, so in this case, what we don't see on these both graphs, so one parser library is basically a library with a small thin layer around this, which will be, I don't know, CLI application that will return the result in the same way as the knowledge graph. The majority of the code is a library, and only thin wrapper around is CLI or these FFI exposed functions. And since we are going to reuse, we're going to use in knowledge graph one parser as a library, and we will compile into knowledge graph application. And we can also do a separate small application, which will only use one parser library and have its own application, if it makes sense.
Yeah,
You
I
know
was
what I
gonna
mean?
say the only concern with of that is just making sure we don't package Kuzu into the embeddings one, right? And anything that
Yes, yeah. So the knowledge graph project is an application like console or whatever, and
yeah.
it will store in the Kuzu, but it will use one parser as a library only, and one parser will have a separate application which will only use one parser library. I think we don't need to use knowledge graph base. It's only one direction, right? Because for embeddings you only need functionality from one parser. Is correct?
Yeah.
Yeah.
And yeah, and we will wrap this library into small, again, for the sake of discussion, CLI application, which will do this, provide embeddings and stuff.
Well, so no,
No?
I don't think there needs to be CLI application for embeddings indexer. It will just
Just for sake of
expose.
discussion, whatever it is.
Yeah, he's talking just a wrap. There will be a Go binding, like the indexer will wrap the one
So
part.
basically, it's a library, but we need to wrap it into an application.
Mhm. Yeah, yeah. If you mean embeddings indexer.
Just want to quickly mention that I think for the proof of concept, using a CLI for the knowledge graph is totally fine, but I don't think we can even launch it on production or should launch it on production like that. I think we should use Gitly properly. So we still need to compare the effort. Maybe it's easier to have file-based adapter and Gitly-based adapter. Basically, the only difference is how we read the files.
Yeah.
Maybe it's not that complicated. I don't know.
Yes, and I mentioned this since how we read files from the directory or from the Gitly it's the smallest part comparing to all the other logic we need to implement in knowledge graph. So by using CLI, we can just start experimenting locally. Because I think it's just a small, it's basically need to go through files and get list of them or their content.
I do like that approach though, Vitaly. Like maybe it makes sense that the embeddings team works from this project and we just expose an embeddings binary crate because these are both gonna this is going to maybe eventually call FFI, or sorry, this is eventually going to call this via FFI. I don't know. Or like Dimitri said, have a separate project for Go bindings, and then there's a Go bindings for knowledge graph and Go bindings for one parser. I don't know. What do you?
Yeah, maybe you can check with the embeddings team what they think about it.
Yeah, I would love to know what Maddie and folks think. My instinct is it would be nice to have it be easy to change what embeddings can access from some of the stuff that knowledge graph is, like for instance node connections and things like that. Right now we're not talking about using that from the indexer, but you know, you could imagine that potentially that could be useful.
Hmm.
I think the main concern for me is the resultant binary size, because that's always a concern for the distribution piece of it. So both GitLab Elasticsearch Indexer and GitLab Zookt. If by using the knowledge graph project bindings, it becomes much, much larger, then it doesn't really make a lot of sense. But if it's roughly the same, it's just easier for us to use the same bindings, or maybe to use the same project with different kind of binding, Go bindings.
But is it really a large binary? Maybe Angela, you can check. Do you compile it? How large is it? And we can, I don't know,
The knowledge
times
graph?
10 it.
The knowledge
Yeah.
graph? Or
Yeah.
yeah.
I assume it's not that much.
No, I can check that right now.
So I was talking about resulting Go binary sizes. So by
Yeah.
including
This,
one
yeah, I don't
or
know.
the other library, how much bigger it will become.
Yeah.
I mean, we can
Yeah, I
do
think
that too.
We can write it down and check later, but
But the Rust binary, I'm pretty sure that you still uses the Rust binary. Like when you compile with CGO, I don't think it actually like uh, I don't think it actually. This is 41 megabytes with Kuzu. Oh no, this doesn't have Kuzu. Um, this doesn't have Kuzu, but I can check in another one. Knowledge graph. Sorry. Old. Yeah. Let's see, target release. Oh, I didn't create. Let me just do that real quick. And then the Go FFI, we can also look at that because I have that built. The Kuzin build might take a while actually. So what's the limit, I guess is the question, Dimitri. Is there a limit?
Not really, but I think distribution is really sensitive to the size of all the components. And they really like that GitLab Zookt is only 14 megabytes binary.
Okay. So someone out, so it's like a self-managed customer is checking it out. They don't like it being what, 100 megabytes or something?
So each additional service, each additional component increases the omnibus size, and it's already really large as it is. So I think that's why it's like that.
Hmm.
Maybe when we have more modular build, when we download components on demand, it will be different. But right now it's kind of monolithic build, if that makes sense.
Yeah. No, downloading would be also complex. We thought about that for the language server. Rather than distributing the binary with the packages, just download it. But I'm thinking, but we can always check the sizes later. In fact, I can, while we're doing that, I can go to the Go parser. Let me type in FFI. There we go. And then I should be able to, I think, 18.5 megabytes with tree sitter and AST grep. So I would assume it's just that plus the Kuzu one. So this built, so target release. Yeah, 18.4 megabytes with Kuzu.
That's not too bad.
Yep. For Mac. Could be way bigger for Windows. I don't know. But it's not too bad. So I'm assuming it would just be like whatever the difference is for the actual C++ compilation for Kuzu, plus whatever Go outputs. So maybe like couple more megabytes than that. Yeah, I just don't know like what's the simplest approach. Maybe it just makes sense that the embeddings team just starts working and gets, their FFI going and we kind of reconvene later and just go with, like you guys were saying, go with the shell approach. And then eventually maybe we can unify the FFI stuff later. I don't know. Um, but embeddings is definitely different than knowledge graph in the sense that, like you said, it's stateless, right, Dimitri? Um, so I'm not sure.
I think we should clarify,
Is
at
it
least on server side, the partial update, because we could make it server stateless too if we define how exactly the output of the partial update should look like. If it wouldn't touch the Kuzu database directly, it could be stateless, but it means more complications that changing the database would need to be done in second step separate from the indexer. So I I think we can take a look at this and then clarify this point.
Yeah, I think, well, at least on the client side, we'll want to, when you make a change, um, let's say I change 4 files, we'll want to know what has changed. Then once we have that data, um, of course, we'll parse it to extract the information. And then, at least on the client side, what I was thinking is we'd run a Cypher mutation to just delete any nodes associated with those files, right? Um, and then re-add them with the new change data as my.
Would it be
Yeah,
possible? Oh, sorry.
it's more complicated because we will need to first store the list of relationships in which these deleted files or nodes are target of the relationship. Yeah. So what existing relationships point to these nodes being
Can you
deleted?
not can you not drop the relationship in with the Cypher mutation itself?
Sorry.
Can we not drop the relationship with the Cypher mutation itself, or does that have to be done?
We can drop, but if we would just delete all the relationships from the files being replaced, then we we couldn't restore. We couldn't. We we would lose some relationships where these deleted files are target. Yeah? For example, if I have a relationship that for example, model called issue calls a method in file merge request, and
Yeah.
I delete the all nodes from merge request file,
Mhm.
then I lose this relationship. Yeah. So before I delete this merge request file, I need to store what other nodes are referencing this nodes from deleted file, if it makes sense.
Would that
I,
be would that be an accurate representation though? I guess like you would if it's not actually referencing anything because the file no longer exists, you would want that relationship to be dropped, right?
but I can just replace some. Yeah, you are right, but I can just change some nodes in the file. Yeah.
Okay. Yeah, if you change nodes in the file. Huh. That's right. Yeah, I think we actually probably need a like to treat the intermediary database just like we would with the Kuzu. Um, just like we are doing with the import, we would probably need to do the same thing. So it makes sense to actually have a key value store.
Would we be able to reuse basically all the client-side logic? Because I think we're going to do exactly the same, perform initial indexing, then perform incremental indexing.
Well, yeah, that's the whole point of using the shelling this is so this can be reused as much as possible, right?
Yeah, we can still reuse it using FFI. I'm just thinking about finalizing this logic, how we're going to perform incremental updates on for both client side and on the backend. Because I think it will be exactly the same.
It'll probably be the exact same, yeah. Which makes me think we definitely need a key value store, like a fast one, and store both states, like the actual graph database state plus the key value store. And at least monolith, we kind of know what we're looking at actually, if you guys want to see. I don't know if you guys saw, I was actually kind of blown away. I wanted to show you guys this as well before we go. So this is just the extraction process. It's not loading it into Kuzu. But I'll open this up so you guys can see. Make this bigger. So like I was showing, I showed Jan and Vitaly this before, but essentially what this is doing is TLDR is taking in like the path that you provide it into the CLI, spins up, first it scans all the files, all the non-git ignored files using the same thing RG uses. It collects all the files, does some like pre-processing for which files are larger and whatnot, so it can prioritize effectively. And then it spins off a few worker threads, or however many threads we specify. So we have fine-grained control over that, which is nice. And we can even look at CPU utilization, etc. But it spins up some worker threads and then builds a file queue. So the file queue has the list of files that haven't been parsed yet, and then the workers just start reading from that queue. So the worker task you can see here, it starts and then it's basically process the file. And the process file uses the one parser library to just to show you guys here, um, parse the code and then to extract the rules and then sorry, load up the rules, then run the rules, and then run the analysis. The analysis is an important part for getting accurate definitions and references. And I can break this down in a separate session on how the Ruby parser is working to get those. And then essentially it's outputting the definitions and the references. So then if I build it and show you guys. So originally it was a little bit slow. And that's what I showed you, Jan and Vitaly. But I didn't realize I was running it in debug mode, and debug mode is just apparently for Rust like way slower because it loads all the symbols and stack traces, etc. So you can profile it and everything. But if you run it like this, and this is pointing to my GDK GitLab folder right here. So if I run this, it processes it, and then we can actually see the definitions and references collected. And then I'll show you guys once it's finished what the file looks like. The reference is kind of large, but but yeah, so found what This could be wrong, but 168,000 definitions and 2 million references. So if I open this up, the definitions is 24 megabytes for the monolith. This is just the Ruby files, so not the JavaScript. So I would double this with the amount of JavaScript, Golang, and Ruby files that we have. I think it's like 100,000 files, and the Ruby files are like 50,000. So I would probably double the data, or maybe even like 3 times it after we extract like all the information that we need. But just to show you what the definitions looks like, the file is kind of large, so maybe I can even load it into like VS Code, so you can see. It might load up actually. Okay, it did load up. Nice. Let me make this bigger for you. It's harder to read, I guess. Do I have a CSV viewer? No, I guess I don't. But you can see roughly here is the file path, but then here's the definition. So tooling, and then this is the rule, but we'll also want to save the node type, right? So for instance, initialize, right, isn't probably an actual method. And so we'll probably want to store this is a method, right? And then build the relationships that way, right? So if it's a method, then maybe to the right of that, we'll have like the from to relationship, or in a separate CSV or whatever we're storing it in. But this is kind of what it looks like. So I've got, tooling crystal ball here, coverage line strategy. These are the modules. It's like the fully qualified name of that specific file. Yeah, same for the rest of these. So I don't really remember too much of the code, but if you guys can give me something you remember in the monolith code base, we can search it right now, if you know any code. You want to,
Zookt node RB.
what is it? Zookt
Zookt / node RB.
/ node?
Yeah.
The file or
Path. So
Zookt?
file is node RB, but it's in the Zookt directory, if I remember correctly.
So Zookt / node RB.
Yeah.
Yep. So we have here Zookt node RB, Zookt node finder initialized by task requests, marking loss enabled, concurrency limit. Does this look familiar?
Yeah, looks great. By the way, maybe you can store relative paths. I think that can save a lot of storage.
Oh yeah. We'll definitely do relative path. I'm thinking like relative path and maybe project. Client side might be different though. We might want to store the full path because
Maybe you can store it once, like in the metadata file or something, because I don't think we need to output it tens of thousands of times.
Well, that's why I would actually really like to use SQLite. It's just the only issue with SQLite is for Kuzu, you have to download an extension, and we'd have to bundle that extension for every OS. That's the only issue if we use SQLite. But SQLite would be nice because then we can actually have a schema for storing all this information, right?
I was just going to mention SQLite because I've heard key value store, and I strongly believe that we need to use library-based key value store like SQLite, because we don't want to introduce another dependency, another binary. This is all this discussion all over again then.
Yes, exactly. That's what I was thinking, like a Rust, pure Rust key value store is what I was thinking. And then we can just version it like in the code itself. Kind of like a MongoDB, but pure Rust is what I'm thinking.
That totally makes sense.
Because there's level DB, there's like bindings for level DB, but I'm like we're already doing a C++ binding. I don't want to do another C++ binding dependency. So I think there's a few pure Rust key value stores out there. which is the benefit of using Rust, but yeah. So, but yeah, so this, and then the same thing for references actually. So I don't know if it'll load references because this is like 700 megabytes maybe. Um, and this might not be nearly as accurate, but because the references are a little bit harder, and also I'm extracting the fully qualified name if it exists. But we can even look in here. So these are all the different calls in that same file that you're talking about, Dimitri. So um, yeah, this probably will need to be improved as far as accuracy, but I try to get it there at least. So for instance, here, like it's calling GitLab database type indifferent.new. Um, online duration threshold.
I think it's already pretty good though.
Okay. I mean, I did my best. I tried to do some basic assignment tracing. I can lead you guys through how I tried that. Again, I'm not a Ruby expert, so if anything, we can like just go with the initial code and then you guys can just tear it apart because it's not probably like, and of course we're not gonna get as good as the compiler, but at least we can expand from there, right? But yeah, were you gonna say something else?
I pasted to Slack link to the comment where are numbers of nodes and edges we got with the POC parser Vitaly worked
Mm-hmm.
before.
Mm-hmm.
There are slightly different numbers, like over 200K of nodes and 600K of edges. But I assume it depends how actually we model these relationships in the final parser. But I think it will strongly, the size of the database and all our estimations will depend actually how we will actually models the relationships, because
Yeah.
I don't now remember what was the size of your Kuzu database now, 700 or something.
For the monolith, I haven't loaded this into the monolith yet, but we can.
Okay.
Um, but the actual CSV itself, uh, let me see. Let's go to the top so I can actually see the columns. So this has, okay, that's why it looks a little ugly. So it has the full match, or sorry, full file path, matched text. So I actually, that's why it's so huge. Let me rerun this and not include the matched text. Give me a second.
Yeah, we don't need to figure out it now. I just meant that the size of database may be highly different depending on what we store in database and how relationships will look like, and also on indexes. I wonder if you already store some indexes or not to
No.
speed up the queries, uh, because these then take some space too.
Mhm. Definitely. That's why it's so big. So I forgot I'm storing the match text because I was debugging.
Okay.
So this
I
is
see.
storing literally the actual matched
Yeah.
text there. So I was gonna say I can literally just remove this and we'll
Mhm.
get a better sense of what it is. Where is it? Let me just make sure I'm removing this. Um, I think that should be fine. I think it should run. Uh, hopefully it doesn't yell at me. And it's pretty great that it can write that much data actually that quickly, like 700 megabytes worth of data. Um, okay, let's try again. Um, we're now down to 300 megabytes. So let's go in here.
I'd be curious to see the size. Let's say if we use the STD or something like that to compress it. But maybe for temporary files, that's not really necessary.
Yeah. That's a good point. We could definitely look into that. But yeah, so 300 megabytes for just so right, like if we go in here into these CSVs, these are where we're going to import directly into Kuzu. Maybe Kuzu does compression itself. So I don't know. But what was the monolith when you guys were in the POC for the indexer that you guys built? What was the size?
I think about 50 or something like that, but indexes were done only on relationships between function calls, if I remember correctly.
Okay.
So yeah,
Cool. But yeah, that's basically it as far as um, everything that I had on my end. Did you guys have any other things you guys want to talk about? Any questions?
oh, it looks great to me. I think, yeah, as for us, section item would be to figure out these partial updates.
Mhm. Yeah.
It would be also interesting to, yeah, but we will know better when we have this parser up and running, at least the basic stuff, or to make sure that the final size doesn't differ too much from the estimations I did in the document design.
Yeah.
To make sure that we don't find out that
It's
it doesn't
actually,
fit into the Zook nodes,
yeah,
actually.
10,000 times the size. Yeah.
Yeah.
I'm thinking
Yeah.
it'll probably be, I mean, I think we should always use the monolith as the benchmark. Because that's extreme example. Um,
Yeah,
what is the
so
size limit is the question.
well, we can configure our size limit. In general, Kuzu is able to work with really huge databases, but we actually need to set some limits, both because of setting also memory limit. For example, if you want to allow 1 gigabyte big database, then you also need to allocate much bigger buffer pool, memory buffer pool for working with such a big database.
Right.
So, so I would hope that we actually by default work with much smaller databases. We have some statistics about what is uh, what is typical, what is percentile balance of repository sizes? I mean, what percentage of repositories is smaller than, for example, 1 megabyte? How many of them are bigger, and so on? So when we know the size of Rails, of GitLab Rails repository and some smaller databases, we can do some estimation what will be projection of repository size to Kuzu database size, if it
That's
makes sense.
yeah.
And just for reference, we have 40 terabytes of data in Zookt, and we have enabled it for 99% of paid namespaces on .com.
That is a lot of data. That is a lot of data. Okay. Yeah, I'm glad we're like thinking about performance and these extreme cases because this is a lot of data. Um, okay. But that's it for me. Anything for you guys? Anything else? Um, we can schedule a follow-up one after we do some async talks. Sound good?
Yeah, awesome. Cool.
Cool. All right. Well, thank you, everybody. Happy Friday. I'll see you next week.
Yeah, bye.
Thank you.
Thanks.
Have a nice weekend. Bye.
Bye.